Buongiorno a tutti e benvenuti al corso dedicato alla digitalizzazione di materiali tridimensionali, di beni culturali. Good morning, thank you everybody for being here and welcome. Here we have Carlos Bayod, that will be the first speaker, who curated this course that is part of ARCHiVe Online Academy 2021. This is the third course of the season. Today is the first lesson, and it's the first class, the theoretical lesson. Tomorrow we'll have the first workshop. Carlos Bayod is part of Factum Foundation, who, as I said, created this course. And well, welcome. I leave you the floor. Carlos, can you hear me?
Yeah.
Great.
Thank you very much, Costanza. Can you hear me?
Yes, sure. Very well.
Well, thank you for the introduction and for organizing this course. I'm going to share my screen now.
Mm-hmm. In the meantime, I remember to all people being here that if you have any questions, please type it on the chat or raise your hands. And Carlos, do you prefer to have the questions at the end, or?
I don't mind if people want to ask questions as I speak, so as you prefer. I'm happy to be interrupted.
Okay, so.
But also at the end will be fine. So
For everybody, feel free to write in the chat, both on Zoom and on YouTube. Also, the questions that you will write on YouTube, I will collect them and forward them to you. So, please.
Very well. Well, thank you again, and welcome everyone. Thank you for attending. This is the course on three-dimensional digitization. And this is basically about how to record in 3D things of our cultural heritage. This is the first session. This course is going to be made by 5 classes, something more theoretical, and then 3 workshops, which we intend to be more practical oriented, as much practical as it could be in an online environment. So over the next month, we will be looking at how we use digital technology to record the shape and the surface of things in high resolution. And this is at the very core of much of the work that we do at the Factum Foundation. This course is going to be mainly taught by me, and also I will be joined by some of my colleagues, some experts in the Factum Foundation who are specialized in the different areas that we will be covering here during the next weeks. I am in charge of the recording of paintings in the Factum Foundation, among other types of projects. So today it's going to be mainly about that, about how to record in 3 dimensions the surface of paintings and other low relief objects. Just to give a little bit of context, the Factum Foundation is a Spanish foundation. It's based in Madrid. It was founded by British artist Adam Lowe, who was also participating a few days ago in giving one of the classes in this ARCHiVe Online Academy. The Factum Foundation is dedicated to developing and applying new technologies for documenting cultural heritage and works of art in general. So we are not restorers. We are not touching the original works of art. We are applying different types of technology in order to record in high resolution the elements that make these objects unique. This is a few of the things that we do in the Factum Foundation. So we are constantly looking for new solutions for recording cultural heritage objects, from paintings to sculptures to architectural elements, archaeological sites, etc. And then we develop our own technology. when we are not satisfied with the available systems in the market. So developing new systems, new hardware and new software is part of what we do and what we have been doing in the last years. One of the most interesting things that we do is that we apply this documentation, this digital information that we obtain out of original objects, into creating facsimiles, into the creation of exact replicas that can help in the preservation of the originals. This is very important to what I'm about to explain today, because we are always trying to demonstrate the quality of our 3D recordings by the possibility of rematerializing this data on a physical environment. We are also experimenting into digital restoration projects, and I will be talking about that in one of the next classes, which is again something that has to do with never touching, never applying any change to the original object, but then trying to propose different restorations in a virtual environment with virtual tools. And then finally, we organize exhibitions, we prepare publications, we organize training initiatives, and we in general are focused and are committed with dissemination of digital technology for the preservation of works of art. So one of the main areas of expertise that has emerged over the last years has been the actual digitization of the surface of paintings. And this is a journey that has taken us about 20 years since we started trying to find what would be the best method, what is the best technology in order to capture the qualities of the surface of a painting in the best possible way. So I'm going to be talking briefly about what has been happening in the last 20 years and why it has been so important for us to be able to capture the relief of paintings in the best possible way, and how we do it and why we think it's becoming a more and more important thing to be done by institutions and individuals alike. So I want to begin by explaining one of the most recent projects. This is the 3D recording of a famous painting that is in the Museo del Prado here in Madrid. This is the Annunciation by Frangelico. And we had the opportunity of collaborating with the Museo del Prado in recording the surface of this panel painting just after a process of restoration. So what is usual in this type of works is that when a painting is about to be cleaned or restored in any way, a series of technical analyses have been applied onto the painting. So the museum was, as you can imagine, applying high resolution color recording, and they were doing ultraviolet analysis and infrared photography and X-ray radiography. All sorts of analysis in order to document the current conservation state of the painting, and especially in order to see through the layers of paint in order to see what's behind. So the restorers and those in charge of the conservation of the panel, they have as much information as possible about the way this painting is preserved. But what we were doing is not about trying to see through the layers in the object. We were trying, on the contrary, to focus on the top layer, on the actual relief of this object, and capturing the subtle details of the surface through 3D laser scanning. So this is what you are seeing now on the screen. This is the process of recording with a triangulation laser scanner that we developed ourselves, the Lucida scanner, which is a system that I will be explaining broadly today and tomorrow. And just after they finished the restoration process, we had this opportunity of recording the surface of the panel in the highest possible resolution with the highest possible quality. So we could obtain what could be as a snapshot, as if it was specific records of how this panel is at this very moment in its historic trajectory. It is important in paintings like this one to focus on the relief and not only on the color and other methods of analysis, because there is so much information that can be found in the texture on a painting like this, that normally when we see a work of art in a museum, in the gallery space, we don't really get to appreciate all the complexity and all the character that is present in the surface. And it is only through 3D scanning that this complexity emerges and can be made visible and understood in a completely different way. Normally, when we look at a painting in a museum, we are looking at something that is perfectly presented with the proper light in a way that we don't get to understand all the imperfections on the surface. So the way museums are trying to show their works of art is through providing a perfect image, a perfect visualization of the work of art, so that you could recognize the same image and the same, and you can have the same and the best possible view from every point of view in the room. So this is normally what you are getting when you are in front of a painting. It's a perfectly flat image of the color with a perfect reproduction of the color, something that could be also recognized in the publication or in the catalog or in any other type of reproduction that is available commercially. But in addition to this type of information, we are interested in providing also this type of data. So this is a render. This is like a visualization of the relief that was obtained thanks to the 3D scanning that we carried out in 2019. As you can see, this image allows you to understand the representation of the painting, whereas this image is actually about the object itself. It's about the imperfections of the object. It's telling us different aspects, like, for example, the central crack that divides the panel in two halves, the left and right hand side of the panels. And that is because as part of the history of this panel, it was just broken in two pieces, which is something that, of course, has been restored and repaired as you know, in the lifespan of this panel. And this is something you don't really get when you are in front of the original in the gallery space. But what is even more interesting is what happens when we look closely at the details. Again, this is a detail of the color information that we captured with a different system, with composite photography. And we can appreciate a lot of details, but then it is only when we combine this flat color data with our relief 3D data that we get to really understand the subtle qualities of the texture. So all these elements, for example, surrounding the head of the angel, this very carefully carved series of details that the artist wanted to be visible and wanted to be present, are essential to understand a work of art like this. And of course, when we remove the layer of color, virtually speaking, it is possible to appreciate them even more. And you get to read this game of levels that the artist wanted to do in order to present the narrative of this painting. These games of texture, the different levels of relief, is part of the special effects that the artist had at the beginning of the 15th century in order to provide the effect of three-dimensionality, the effect of space, and this level of planes that are happening, for example, when the hands of the angel are actually coming towards us, towards the viewer, just by having the background pushed back in the relief. So this play of positive and negative reliefs is defining this type of art and this type of painting. And it's really visible. It is actually only something that you can appreciate when you are combining the color information with 3D information. This type of data was captured with a 3D scanner that was developed by Factum Foundation over the last years. And now we are applying into the analysis of hundreds of paintings, working in collaboration with the top museums in the world. But the necessary process to have this instrument, this tool that allows us to look at paintings in this way, it is something that started about 20 years ago, recording another very different series of reliefs. In this case, we are talking about the reliefs of the tomb of Seti I in Egypt, in the Valley of the Kings. And this is what I would like to share with you today, a little bit of summary of the evolution of the approach to recording objects in low relief and what is necessary if we want to adapt this technology into recording the most difficult of all the possible objects, which is the surface of a panel or a canvas painting. In 2000 or 2001, we were working in the tomb of Seti I. This is one of the most interesting and the largest and the most richly decorated royal tombs in Luxor, in the Valley of the Kings. And we were using the technology that was available at the time and adapting it in order to be able to capture as much as possible and with the best possible resolution the wall paintings and the wall reliefs of the sarcophagus room in the tomb of Seti I. We were doing this as a way to demonstrate that high resolution 3D recording technology is something that can be applied effectively and really in a very useful way to the preservation of original artifacts. The tomb of Seti I, as it is the case with many other archaeological sites in the world, and especially in Egypt, are in danger of rapid change and rapid deterioration over time, and also because the way they have been treated and the way they have been visited over the last decades. So it is not uncommon that some of these archaeological sites have actually been closed to the public precisely to preserve them for the future, in order to have them as protected as possible for the future generation. So we believe, and this is something we started experimenting and we started researching about 20 years ago, that digital technology could be an answer in order to help preserving these important monuments at the same time as you could keep them as something that you could visit. So the reason for recording a monument like this, it was not only to obtain a set of digital data that we could archive and we could use for research or analysis. It was also, as you can see, for example, in the last image on the screen, in order to create a physical reproduction of the data. So the reliefs that we were recording with a laser scanner, they have to be something that you could rematerialize through different prototyping technologies, for example, routing machines or milling machines, and be able to have something that is a perfect restitution of the same original reliefs that you are recording. At that time, we were adapting the technology that was available in the market. We were using a scanner that was called a Verrà scanner. It was a kind of laser scanner that was using the triangulation principle. So by projecting a laser line on top of the surface, it was possible to use two digital cameras for capturing the distortions of the line as the scanner moved across the surface. What we did was adapting this system, this scanning head, onto a structural frame so that we could record columns, or let's say vertical modules of the wall in the most systematic way possible. So we could really follow a process that is systematic and is really useful for large areas of wall. The intention was to actually being able to capture an area of about 16 square meters in order to create a first facsimile, real size reproduction of that section of the wall, including color and relief information. This is a black and white image of the reproduction that we did at the time as a demonstration that this was actually possible. And of course, the reproduction is the result of combining digital technologies with craft skills. In our workshops in Factum here in Madrid, we have teams that are experts both in the digital tools and also in the physical tools like sculpture, painting, molding, etc. So it was possible to actually create this replica of that section of the eastern wall of the sarcophagus room of Seti I already 20 years ago. So I want to jump again to almost the present time, and I want to show you the comparison between the data that we were capturing in 2001 with the information that we are capturing in 2019. This is interesting for us because it demonstrates that the approach that we were trying to follow 20 years ago, it is valid today, and it is something that is still setting like a benchmark, like a proper measure of the quality that we think it is necessary for this type of works related to cultural heritage. We have been working in Egypt for many years, and especially in the last 4 or 5 years, we had the opportunity to go back to the tomb of Seti I in order to record not only that part of the wall, but the full area of painted reliefs that you can find in all the different rooms, in all the different corridors. We are talking about hundreds of square meters, and we have been recording them in color with high resolution panoramic color recording, and also in 3D. This is an image of that section of the wall I was talking about, recorded in 2019. This is the area that we captured in 3D. And this is more or less the same area that we could also record in 2001 with that very initial version of our laser 3D scanner, the Reversa, mounted onto a modular structural frame that we ended up calling the SETI scanner. What is interesting here is that the quality that we are recording now with the system that I was just showing you before, applied in the Museo del Prado for a painting, it was already sharing a lot of the qualities that we were capable of recording in 2001. We can go even closer in the detail, and we can see that the information, it is there. So this is the recent recording. This is the previous recording. And you can see that every single detail in the surface of that wall that we could be interested on as conservators, it is also there. It is visible, although it is true that the previous recording, it contains a bit more noise. So as you could see, the small areas of black dots, which we call noise, is like artifacts that are not really present in the data. It is something that we managed to improve over time, but the actual information, it's already there. This is in a way very encouraging to us because we are constantly looking for different ways of recording the surface of things. I wanted to show you very briefly what other teams were doing at the beginning of the 21st century, so you could have an idea of how this field of trying to capture the relief of things has been evolving in the last years. This is a very famous project. I'm going to show a few images of projects that are not Factum related, but this is something that was very famous at the time, just at the turn of the century, in which the team by Marc Levoy were using laser scanners to document the full figure of Michelangelo's David statue in Florence. This was something that was published a lot. It was really interesting at the time about how they could apply 3D scanning technology outside of the laboratory and bringing the system into the museum in recording something that logistically was very difficult to do, because they were trying to document and they were actually managed to record the full shape of the sculpture and trying to record it with enough resolution as to be able to capture not just the general shape of the figure, but also the marks on the skin that could tell information about the chisel, about the actual tool that Michelangelo could have been using to give shape to this sculpture. So it is one of the first attempts of applying 3D scanning technology to a sculpture with the intention of going beyond usual resolution and trying to go into the actual recording of the texture of the thing. Applying 3D scanning technology to paintings is something that it's really what we care about. And other teams have been applying different systems of 3D scanners, for example, white light scanning systems or structured light scanning systems, also for recording panel paintings like this one by Leonardo. But in order to capture the shape of the panel and in order to try to understand the distortions of the panel, of the actual material over time. So this is a research that was focused not actually on the layer of the painting, but mostly on understanding this panel painting as a sculpture. It's trying to understand painting as a volume so that it could be measured and it could be monitored over time with regards to how the different panels, how the different sections have been moving or how they have been distorting over time. This is information that is, or that was supposed to be useful for those in charge of preserving or restoring a panel like this. And then, of course, the attempts by the Canadian team of François Blaise about looking at applying laser scanning technology onto recording the Mona Lisa. It was also considering the panel as a sculptural shape in the sense that they were trying to obtain like a 3D model of the panel, that something that you could actually understand as a 3D object. But then they were trying to obtain also information about the details of the paint layer, the subtle differences in relief that were possibly to be seen on the actual paint layer of the Mona Lisa. These are some examples of what other teams were researching at the time. In our case, the difference that we were trying to achieve is that, as I was saying before, our aim from the beginning was to digitize objects in 3 dimensions in order to be able to reproduce them as facsimiles, in order to create exact replicas that could become material at the end of the process, not just something to be seen on the screen or in a virtual environment. So the reversa scanner or the SETI scanner that we were using in Egypt, we were trying to apply it to different types of objects that we were working with. So for example, in the Biblioteca Nacional in Madrid, we were trying to apply the same laser scanner to documenting the famous Beato de Liébana, one of the most important manuscripts in the collections of the Biblioteca Nacional, with some success, with a lot of problems as well, but trying to understand these pages and these texts as something that had not only value from the 2-dimensional point of view, but also from a 3-dimensional perspective. Of course, applying 3D scanners, especially laser scanners, to sculptures is something that we were doing for the recording and reproduction of the Dama de Elche. Something that we could only achieve in relatively flat areas of the sculpture, because the way that the SETI scanner was developed was to actually record areas that are relatively flat in the surface, but with the importance in the relief texture. So for recording a volumetric sculpture like this, a volumetric object like this one, it was necessary to use the combination of different systems, laser scanning in different modalities, but also different ways of approaching the capture of shape and surface. For digitizing Assyrian reliefs in the British Museum, we were also using the laser 3D scanner. And of course, in the tomb of Tutankhamun, when recording the 4 walls of the funerary chamber, we were experimenting with the SETI scanner, trying to capture every detail on the relief in the walls. But then the problem came when we tried to apply this scanner that, I remind you, it was modified by us in terms of the hardware and software. The problem came when we tried to document the surface of paintings that are usually varnished, so they are glossy, they are not matte, and also they have very contrasting areas between dark and light colors. This is an image of when we were applying the 3D scanning technology on the Marriage of the Virgin by Raphael in the Pinacoteca di Brera in Milan. And we were using a similar principle that what we were applying in the tomb of Seti I. So understanding the surface of the panel this exactly the same way as if it was the surface of the wall. So recording in columns or modular sections, and then trying to obtain the shape and the texture of the panel with the highest possible quality. But then it was really not possible to achieve a proper quality in paintings that are heavily varnished, that are very reflective, because the scanner starts to interpret changes of contrast, changes of tone, as if it was a change in the actual relief. It's a series of artifacts that are common to other scanners and that are effectively present in this scanner that we were using. So this is why we decided in 2010 to start the development of our own laser scanner. This is an image of the typical napkin when at the beginning of every project you make a brainstorm of ideas about what would be the ideal scanner. What is the qualities that we are asking for a scanner to have if we want to be applied specifically for the conservation of paintings. So in collaboration with the artist and engineer Manuel Franquelo, we started the development of a new scanner that was from the beginning, almost from scratch, focused on capturing the difficult texture of the paintings. The principle is the same. We are talking about triangulation scanner. So it's about projecting a laser line and then having a camera, a black and white video camera that could capture the distortions of the line as the scanner moves across the surface. We were experimenting and we were building different prototypes, first with only one camera, then adding 2 cameras positioned at 45 degrees so that we could project this laser line. And then by moving the scanner head in parallel to the surface or the object we want to record, it was possible to obtain a series of video frames. We are just interested on capturing black and white video frames of the shape of the laser line when it hits the surface of the object. We are not recording color here. We are just trying to record the shape and the texture of something through recording black and white video. This was as simple as that. And what you can see, for example, in this image is the product of one of the first tests by combining the information captured with one of the cameras, then with the other camera, and then the result merging information from both of them so that we could obtain the best possible quality. So the Lucida 3D scanner which is the name that this system has, is something that has been evolving over the last 10 years from the first prototypes developed in 2010. But the principle is something that was very successful from the beginning. We had the opportunity of recording paintings and different types of surface that contain all the difficulties that we were having in the previous years, and we were capable for the first time to overcome these difficulties and obtain proper information. So it was in 2011 when we had the opportunity of using the Lucida 3D scanner for the first time to record one of the original paintings in the collection of the Museo del Prado. This is a panel painting by Rubens from first quarter of 17th century. It's called the Triumph of Eucharist over idolatry. And it's a panel painting that contains all the different elements that it would have been impossible to record just a few years ago. The surface was heavily varnished, was very glossy, and as you can see, it contains all the different areas and the full contrast between dark and light elements. But what we wanted the Lucida to do, what we wanted this new scanner to focus on, is to ignore the color and try to focus on the actual relief of the surface. This is the type of information that we were looking for, and thanks to this system, we were capable of obtaining back in 2011. As you can see, it is possible to see the painting from a completely new perspective, from a different point of view. We are not looking at an image anymore, but we are looking at something that looks like a landscape. It looks like a topography in which the different mountains and valleys that are actually giving the shape to this panel are for the first time clearly visible thanks to this act of removing the color. When we look at the details, we understand why we are talking about high resolution. So the Lucida scanner, it's something that we designed to record 3D information with a resolution of 100 microns. And this means that there is a point of information every 10th of a millimeter. This is more than enough for conservation purposes, for dissemination, and for studying a panel painting, and for studying paintings in general. So we kept developing the system after this initial test in the Museo del Prado. This is Frankello working on advancing new developments. And the goal was to convert this initial prototype into something that could be more robust, something that could be more reliable, and something that we could actually take to different places, to different museums, to different archaeological sites, and to be able to work also with higher areas and larger originals, because we wanted clearly that a system like this was something that had to be used extensively, something to be used not only for capturing one painting, but actually for recording entire collections of paintings. This is the way we actually see this system as something that should be useful when you are actually applying it in a systematic way, maybe as part of the different equipment that a museum has in their technical departments. We're also trying to make the system very open and avoid this idea of creating a black box, so that all the internal mechanisms of the system could be easy to repair, easy to understand if we wanted to change any of the components, everything very transparent and open, so that we could create an object that is at the same time easy to use, easy to understand, and easy to operate, something we could take to every place, something that you could transport actually, but also that you could understand and redesign and upgrade as you need it. The result of this system, which is the prototype that we are actually using now, is something that we have been applying to all sorts of materials, not only paintings, but also maps and frescoes and manuscripts, textiles, all sorts of materials in order to try to capture the skin of things, because over time we have been more and more aware that it is necessary to look at the skin of things to understand the biography of the object. It is through the historic trajectory of works of art. It is through the actual recording of their texture that you could really get to understand their history. This prototype of the scanner, it's something that we were using again in the Museo del Prado, but in a few years later, in 2014, to document one of the most important series of paintings that are in their collection. I am talking about the Black Paintings by Goya, which is a series of 14 paintings that were originally part of the house of the artist. They were actually painted on the walls and in the early 19th century, but then they were transferred onto canvas as a way of making them accessible to be part of museum collections, to be part of different exhibitions. So the house where Goya painted this series of the Black paintings is not existing anymore, but the paintings can be seen now in the Museo del Prado as canvas paintings. So as you can imagine, the surface of these originals has changed completely over time, not only because of the radical process of taking the paintings out of their walls and then transferring them onto a new textile support, but also because of the different restorations and adaptations that have been happening over the last decades that have made these paintings very interesting documents to read, especially through the surface. We are talking about paintings that have been analyzed intensively. They have been studied with all sorts of technical analysis. But until then, until the year 2014, they were never documented in 3D. This is why this project, which is mainly a research project that we were doing in Factum in collaboration with the Museo del Prado, this is why it was so important at the time and even today, because it was the first time that it was possible to apply a 3D scanning system to the surface of paintings, but not to record just one as a demonstration, but to record an entire collection, a total of about almost 40 square meters of data, so that we could demonstrate how reliable a system like this could be when you want to record entire collections, and also how easy it is to be part of the other types of analysis that are common use in museums, such as X-ray, infrared, or color photography. You could see that the Lucida scanner had to be adapted to work on very large paintings, mounting the scanning head on top of new structural frames in order to record paintings that are maybe about 5 meters long. And this is something that was done working very closely actually with the different departments in the museum. And it took about 2 months of working with the scanner and the paintings being studied and analyzed as part of a very complex initiative. The results of this initiative have not been published yet, so the Prado will be the first one to decide when they want to make these new visuals of the Black paintings for the first time. But it is clear that there is so much information that you can capture out of analyzing the texture of something like this. The interest of the museum for the texture of this painting, it's actually not new. And it is interesting to see how, for example, a painting like this, the cattle fight, was also documented in raking light, which is a technique of trying to understand the relief of things, of course, without 3D scanning, but through a special way of lighting the photography of the painting. So they were trying to communicate the conservation state of a painting like this by showing this type of images, trying to highlight the state of the surface. So it was very interesting to see that what they were already doing and publishing in their technical bulletin in 1984, it was then done properly with a proper 3D scanner 30 years out in 2014. I would like to propose to do a small break, 5 minutes for a glass of water, for a coffee break, and I suggest to come back again in 5 or 10 minutes time. And I would like to welcome you to make any question if you want about the information I've been showing you so far. Is that okay, Constanza? Can we do it like this?
Yes, sure. I think 5 minutes can do.
Very well. We'll see you all again in 5 minutes.
Yeah. think we are back to start. I would just remind to people listening that for the slides of the lessons and for the attestato di partecipazione, for the document, the informal document that we share for attesting your participation. You can type, you can send an email to info.aoa@cini.it. I'm gonna type it in the chat. And for any other questions, we are here to answer.
Okay, I will share my screen now. Is there any question that anybody wants to ask before I continue? Any comment? Okay, so I will. I was explaining how this type of collaboration with the Museo del Prado were important in order to redefine the importance of the relief of paintings. They were pioneering some of the studies about how to look at the texture through other methods in the past, like raking light, etc. This is, for example, an image of the panel by Rubens that I was telling you before. So again, another example of why this type of approach was necessary and was relevant is that when you are recording a painting like this, it is giving objective and measurable record of how the object is before it changes even more. So we had the opportunity of recording the panel by Rubens before a restoration process. In this process, what the Prado was doing was actually removing this perimeter of the panel painting that was not part of the original work of art. As you can see here, the initial work by Rubens was just smaller in size, but then at a later stage, it was extended with this series of additions that the Prado was then removing as part of this restoration process. This is something very visible and very evident when you look at the 3D data that we captured, because you can see that the wooden material is just different, it's going in a different way. So what happened is that the Museo del Prado created this temporary exhibition showing the part of the painting that was removed. You can see on the right-hand side of the image, the frame with this perimeter part of the panel that was taken away. And then what they did, they asked Factum to create this white plaster reproduction of the panel painting as it was recorded with the Lucida scanner. This was a very interesting approach because it was possible to understand what was the size, what was the shape and the texture of the painting before the restoration process. So in a very transparent way, the conservation department of the museum, they were trying to make the people aware about how much paintings are actually changing as part of conservation treatments. This exhibition, it was about showing a series of panel paintings by Rubens that were actually sketches for tapestries, for a series of tapestries that are known as the Triumph of Eucharist. So in this exhibition in Madrid in 2014, they were showing, as you can see, the panel paintings together with the tapestries that are preserved in another site also in Madrid, so that people could understand that one is the sketch, is the preparatory drawing or the preparatory painting for the main artwork, which in this case is the actual tapestry. And then they were also doing something very interesting. They were showing the panel paintings, the originals, without any protection at the back. So they were showing the work that was being done in order to preserve these very fragile panel paintings so that people could see the back and understand the complex process of restoration that was involved in preserving these panels. This is an image of José de la Fuente and George Bisacau, some of the best world experts in panel restoration, and they were in the process of repairing these panel paintings that have been very deteriorating over time, precisely because they were forced to have a perfectly flat shape over time, and this has been creating very radical cracks and distortions on the front part of the panel. So what is evident in the last years is that in the world of conservation, they have become more tolerant to having panel paintings that are not perfectly flat, that they can have some curvature, they can actually have some shape, because that will be eventually better in order to preserve the front side of the painting. So what they were doing in the Prado, they were creating these very sophisticated ways of having a support frame for the panel, but allowing at the same time a very rigid support, but some flexibility of movement, because the important thing in this type of works is to allow the different materials to move freely, one respect to the other. So with this was more common in the past. Nowadays, the temperature and humidity is more under control in museum environments. But in any case, any small variation in size or in shape that was happening to the panel, it was possible to be absorbed thanks to this type of new adjustments through springs that were joining the original panel to the new frame in a new and innovative way. So this is what they were showing, the back of the panel as part of the show. But then it was also important to be able to show the plaster reproduction of the 3D scanning, so they could understand how the painting was before the restoration process. So once we had this working system, the Lucida 3D scanner, that we have demonstrated that it was possible to be used for documenting collections in museums, for research and for dissemination and for reproduction, then we went back to the tomb of Seti I for recording the rest, let's say the whole area of wall reliefs that we started to work with in 2001. Thanks to having the Lucida scanner, it was possible to capture not just the relief of the figures, as you can see, but also the different imperfections, the graffiti and the marks and the incisions that were present on the walls, because this is at the end what is making this type of recordings unique. In the case of the panel by Rubens, the importance was to record the painting before the restoration process, so we could have a proper records of how this painting was before the treatment. In the case of the tomb, what is happening is that we want to be able to record its current state of conservation, so that whatever happens to this monument in the future, at least we can count with this proper record of the full area of the walls. And this is actually where the value lays in a monument like this, is the complex relation between the shape of the walls, the relief, and the color that is still present on the original. In 2016, we had the opportunity of going back to work in the tomb in collaboration with the Egyptian Ministry of Antiquities, so that we could establish a working team composed by local operators. And this is also an important part of what the Factum Foundation is trying to do. It's about how to transfer this series of technologies and skills to the local people so they could actually learn about how to apply digital techniques to preserving their own monuments. At the end, we want the social and economic activity of these important sites to be active. We want that these monuments are something that people could go and visit. We want to keep alive the industry of the tourism in these areas because it's so important for their economy and for their society. But at the same time, we think that through digital technology, it is possible to actually separate the act of preserving a monument from the experience of visiting a monument. And this is what we are trying to achieve when recording the tomb of Seti I, exactly the same way as we were doing with the tomb of Tutankhamun. The process of recording this Egyptian tomb is also very interesting in the sense that it is a research project that goes beyond what is going on in the actual site in Luxor. Since 2016, we have been applying these technologies for recording also all the different fragments in the tomb that you can now find in other museums throughout the world. So for example, small fragments that you can see in the Boston Museum of Fine Arts, or sections of walls that have been removed from the original tomb of Seti and are now visible in the Louvre Museum in Paris, for example, or in the Archaeological Museum in Florence. It's something that will be part of this digital recording of elements, so that the amount of information that we are gathering, that at the end will be rematerialized as a facsimile near the original, so that people could actually go and see the original place and the replica, it will be even more complete than the original site. We want that the facsimile that we are building, that we are making with the data that we are capturing, contains also the information from fragments that are recorded in other museums in Europe or in the United States or in other places in the world, so that the facsimile that people could visit is even more complete than when visiting the original. We think that this is a very interesting approach, and it could be an answer to this idea of sustainable tourism, because when you are effectively creating facsimiles of something that is very fragile, you are making possible to have a real experience in front of something that you know that you are you are not in front of the original, but you are helping to preserve the original. And this is at the end the goal of the Factum Foundation, how to apply this type of technologies to preserve the original monument or the original object. One of the recent projects that we have been doing is how to promote the use of these technologies and the importance of the relief as part of exhibitions that are showing at the same time original objects and replicas. In 2020, we were working in Bologna, in the Palazzo Fava, in an exhibition that was trying to show all these different technological processes, because this exhibition was kind of a retrospective show of the work of the Factum Foundation in the last years. So we were showing works in progress. We were trying to share with visitors not only objects that have been finished and are the results of our work, but also intermediate steps, also in a way the prototypes and the unfinished elements that are important for us to explain how digital technology can help the preservation of cultural heritage. The first of these rooms at the end is something I want to explain only the first of the rooms, because it's mostly related to the relief of paintings. It was dedicated to showing the relief of a series of paintings and masterpieces and sections also from this Egyptian tomb of Seti I, but without the color. So this room was dedicated to showing the texture of things without the color. It was a white room. At the beginning, what you could see is something not very easy to recognize, but we were showing paintings by Van Gogh, by Monet, by Goya, Rubens, Francesco del Cosa, Ercole de Roberti, also Frangelico, as real-size reproductions, only with the relief, similar to what we were creating for the Museo del Prado just a few years ago. This exhibition was made because in the main floor of the Palazzo Fava, they were showing the reconstruction of the Politico Grifoni, which is an altar piece from the end of the 15th century, from one of the best representations of the Bolognese Renaissance panel painting. And the Politico Grifoni is a series of facsimiles that we were making in the last years in order to bring together a series of panels that are actually scattered in different museums in the world. So it's the same idea as what I was showing you before about the tomb of Seti I and their fragments. It's a similar idea, how to use facsimiles to reunite elements that are actually separated forever, originals that are not visible together, in order to understand the narratives that they were actually playing together when they are seen as a unitarian object. This exhibition, the reconstruction of the Politico Grifoni, it was showing our facsimile together in the same room with the original panels that they were on loan from the different institutions. But then in our own show that we were showing the elements from the Factum Foundation work in the last years, we were actually showing these panels of the Politico Grifoni without the color. And this is something that at the first time, it's something you don't really recognize what's going on. But then thanks to this system of breaking light that we created in order to be able to project a proper lateral light on the surface, it was possible to paint the paintings with shadows and light in a way of converting them into actual reliefs, similar to what we were trying to do digitally with this type of images I was showing before, but in this case, in a physical element, as a physical object. The exhibition, The Aura in the Age of Digital Materiality, was precisely about that. It was actually about how this experience of looking at physical objects in a different way, it's possible thanks to digital technology, and how you can obtain a very authentic experience in front of something that you know is not an original, but you know it has all the visual qualities and all the complex character of the original. And actually the catalog of this exhibition was playing with this idea of looking at a painting with and without the color, highlighting at the same time the artistic version of it through the image, but also its material qualities through the texture. This is the panel of the Annunciation by Frangelico. This is what the same panel that I was showing before, but in this case, a reproduction without the color. You can see that we placed two lines of raking light at both sides of the panel. You can see actually the crack that goes along the middle from the top to the bottom, dividing the panel in two, exactly as it was in the original recording. And we also included the predella. So it's the bottom panel that is also part of the Annunciation work of art with its own line of raking light, so we could illuminate it from the top. this way of presenting the painting was highlighting something that is not really visible when you are looking at the original in the museum. This series of details that the artist was trying to apply to the surface of the painting, for example, visible in the representation of the flowers and the different plants in the Garden of Eden. And of course, the same elements that I was sharing with you before, this subtle game of three-dimensionalities that Frangelico was trying to create in their figures, in the angel, but also on the Virgin, just by having the hands slightly raised with respect to the background. All these things are possible to see on a white surface, as long as they are properly illuminated with Reiki light. So I want to try to share with you a series of questions that are emerging out of this type of exhibitions. When we are looking at comparing the color information and the relief information, some reflections can appear. It is clear in a painting like this. We are talking about a panel painting in tempera from 1425, more or less. And it is clear that there is a direct relation between the elements that are being represented by the artist, for example, the figures, the heads, the hands, or the flowers in this case. There is a clear relation between what is represented in the painting and its translation into texture, because of the technique of tempera, because of the particular way of understanding this type of aesthetics, the way the art concepts were being developed at the time. They create, as you can see, a very direct relation between the color and the relief. It is possible, for example, to follow exactly the silhouette or the line of the contours of the figure just by looking at the relief, even if we are not looking at the color. This is, for example, obvious in details like this one, the feathers of the angel wing. It is one of the most characteristic elements in this painting. And you can see that even if we remove the color, we are understanding exactly the same shape of the feathers. We are understanding these incisions that the artist was making on the surface in order to create this game of reflections of the light. But then we have been recording more than 200 different paintings in many museums, in many collections around the world. And we have been realizing that in more modern ways of painting, then this direct translation between the color that is being represented and the texture surface that is being captured by the 3D scanner is no longer so direct. There is no so much relation between the texture and the relief and between the figure that the artist is trying to represent. This is obvious as we start looking into the technique of oil and the paintings of oil on top of canvas. It is more and more clear than the effects of three-dimensionality, the effects of spatiality are not dependent so much on a direct translation of relief. On the contrary, if we look, for example, at the recording of a painting by Tiziano, we can see that it's more about special accents of impasto, special ways of providing points of attention for the light to reflect so that we could have this recreation of volume and light and space, but in a more subtle way of playing with light. The analysis of this type of paintings, we are now talking about, for example, Velázquez in their early paintings, early 17th century. We are looking at something that, in fact, it has very shallow relief, very low texture, but the specific reflections that the artist wanted to give to certain elements, to certain representations of materials, the way he was trying to describe the light inside the scene, it is made thanks to special impastos which have their specific relief, something that it is possible to capture with a 3D scanner, but it is not a direct relation between the figurative and the relief. Even with the artists that are characteristic for having a very textured way of working with a lot of materiality in the paint, like Rembrandt, for instance, still we cannot really see a direct comparison between the figure and the texture and the landscape that is being possible to obtain with the 3D scanner. So this, I think, opens up a new way of looking at this way of understanding art history through the relief. We are not trying to understand so much the images that are represented, but we are trying to look at the landscape that the relief is making as a result of the specific technique. But then, as we were approaching to more recent ways of painting, we are now getting closer to, for example, Impressionist paintings. We start to look again at a more direct relation between what is being represented and the texture that is being created as a result of it. This is something I just want to share with you as a work in progress, not any conclusion, but it's something that it is more and more evident as we are having the fortune of recording more and more paintings. As we get closer to the abstraction way of painting, as we are getting closer to a new modes of looking at reality, more based on representation illusion and representing subjectivity of the artist, then we are going back to this direct relation between what is being represented as a painting and what is the result as a relief. And of course, if we look into abstraction, if we look into the avant-garde, if we look into the expressionist way of painting, we are certainly looking at something that is a specific and very direct translation between what the artist is representing with painting, with color, and what is the result from the object point of view. This is what I wanted to share with you today. Again, this is not nothing as a conclusion. This is just an opening way of showing some of the ideas that are important for us as Factum Foundation. And they are all coming through the possibility of recording paintings from the three-dimensional point of view. This is thanks to the Lucida scanner, and this is an ongoing work and ongoing research. So I would like also to hear your comments and your questions. And tomorrow we will have the opportunity of looking at how a system like this is actually working. We will try to show you how it is operative and what are the different ways of looking at a painting that are possible because of this system. When me and my team are arriving to a museum and we are in front of a painting, we are trying always to look at ways of recording the surface in the most efficient way. So we are trying to look at the object instead of the image that is represented in it. So in a way, this is what I wanted to share with you today, this rather particular way of looking at this type of objects. And I will be very happy to answer your questions or comment with you about these issues. Thank you very much.
Thank you. We have already a couple of questions. I think that more will come. Well, let's start with the questions that I see here. So from a more practical point of view, I think you mentioned the type of light of Lucida, but maybe tomorrow you will deepen this part. Anyway, Gaia asks, are there any concerns about the light hitting the paint?
So it's a question that we are normally asked in museums. What we are using specifically with this system is a type of laser diode that is not emitting any heat, is not affecting the paint layer at all, because we are not talking about something that is provoking any change of temperature, for example. So it's similar to a barcode reader, similar to what is used, for example, in supermarket to read barcodes. So in that respect, there's no concern about the light of the laser on top of the surface of the painting. And this is something actually, as you could see, that has been used for more than 20 years on all sorts of works of art. Concerning the flashes, for example, I did not talk today about the actual recording of color. When we are working with panoramic color photography for recording the color of a painting, we are using flashlight. We are using flashlight in a way that allows us to obtain the most flat surface as possible. And that means that we don't want any shadows, we don't want any reflections on our color photography. So we are capturing the same painting from two different directions of the light, from the left and from the right, and then we combine this information together. So what we obtain is a perfectly flat representation of the color. If you think about the amount of time that the flashlight is actually hitting the surface, we are talking about a very small fraction of a second. So it is equivalent, let's say, to 1 or 2 minutes, for example, I'm saying just as an example, of the actual light that there is in a museum. So if you want to balance, if you want to compensate for the possible damage that a flashlight is causing to the painting, you just have to turn off the lights of the gallery for a few minutes and you would be already compensating that. Not to mention that nowadays flashes, professional flashes have UV protection filters. They have different measures to make them perfectly usable on top of fragile paintings.
Thanks. Other questions concerning more the replica, the materiality of the replicas. So how do you choose the material of the replicas? If it is similar to the material of the original, or it is chosen to best reproduce the visual properties of the artwork?
Thank you for the question. It is actually the second. So we are focused on creating a visual restitution of the original. So sometimes, I mean, most of the times, we look for those materials that can give us a better possibility of reproducing those visual qualities. For example, when we are reproducing a canvas painting, and I will be able to show you more examples in the next sessions, we have been researching into creating a type of skin, a type of textile that can contain all the qualities of the relief, as well as all the qualities of the color, into a flexible material that looks like canvas. Because if you reproduce a canvas into something that is rigid, that is solid, if you want, the effect is not really the same. But the focus is really put on what is the material that could reproduce better the visual qualities that we were capturing with the different scanning systems. The process is usually the same, no matter if we are recording a map or a canvas or a manuscript. It's about capturing the 3D and color with different systems, and then putting this information together in a digital way. And then we have to reproduce that information back into a physical world, again, with its own particular system. The way we are reproducing relief, and this is something that will be explained in detail in the next sessions, is through this technology of elevated printing. It's a technology developed by Canon. And we have been working with them in the last years to create something that was more suitable for cultural heritage. So that this elevated printing technology is effectively as if we were trying to 3D print the relief of paintings through the accumulation of layers of ink mixed with resin. So this is the first part of the process. So we convert our information from the 3D scanner into something that can be built in layers with very fine, very shallow relief of a few microns into something that actually contains a true representation of the relief in high resolution. This prototype, I mean, this first rematerialization of the data, then we can treat it exactly as if we were working with a sculpture. We can make a silicone mold out of it, and we can make a cast in a different type of material. And this is what we are trying to do in most of our work. It's a complex process that requires many steps and involves not only the digital tools, but also the physical tools necessary to convert something from the digital to the physical.
I think that in November there will be a focus on especially this part, if I remember well.
Yes, correctly.
Like the practical material part.
Absolutely.
I have a technical question. Maybe it's not easy to explain it. So I was curious, you were saying that the passage between the SETI scanner and the Lucida 3D have been made during a period of development that have been, I don't know if really long or not, maybe yes. You researched a lot. And so you were mentioning the problem of glossiness in the varnish on the surface of paintings. And so I was curious to know more or less, how did you overcome to this problem? If from a, how?
Thank you for your question, Costanza. It's actually the main element of this scanner, how to overcome the problem of the varnish, and the way the varnish is increasing the blacks and increasing the tonal range between the blacks and the whites, which for other scanners they were interpreting that as a difference in relief. So we didn't want that. What we wanted is that the scanner could be reading the best in the dark areas and the best in the white areas, so that the Lucida scanner, and this is one of the important creations of Frankello, is that it incorporates an automatic system of overexpose and underexpose. The cameras are capturing at the same time areas that are underexposed and overexposed, and then they are using the best data for each frame. So at the end, we are effectively like recording the same area 2 times, because we are using the best of having, let's say, a low laser exposure and a high laser exposure. This is the main feature of the scanner, actually, and this is what is allowing us to put it in front of something like, for example, the black paintings by Goya, which are effectively very black and very glossy, and being able to record them with enough quality with only one pass. In previous times, it was necessary to do different scans, changing the exposure, changing other parameters like the threshold of the cameras, etc., and then combine these different scans together. And thanks to the scanner that we developed, this is done in the same first scan. So it is allowing us to actually overcome the problem of paintings in museums. Because when we are focused on wall reliefs, for example, this is not so much a problem. When you are trying to record the 3D of a fresco, which is usually a matte surface, this is not so much a problem. But as you could see, the real issue comes when you are trying to focus on the very glossy surface of the paintings.
Very interesting. And still talking about the black paintings by Goya, you said that is it the work still going on or is it finished?
So that recording project was done in 2014.
Okay.
And it was meant to be a research project. So we prepared the information and we gave the original and final files to the Museo del Prado. Since then, they have the data in their archives, and it is up to them when they want to make it public, maybe as part of an exhibition or in their website or a publication, we don't know. So it is really up to them to use the information to analyze it, to study. And what is interesting about this research is that we were capturing the color and the relief layers, and then the museum were taking the other types of analysis like X-ray, infrared, ultraviolet, also all photographs from their archives. So we were creating these multi-layer files, bringing all this information together in the same place so that you could be playing with the layers of information. You could maybe turn on the layer of relief and then turn off the layer of color, or you can visualize a combination of relief and X-ray. This idea of a multi-layer information is very important to understanding a painting. And this is what we have provided to the Prado, and this is also what we have been doing in other projects with other institutions, the possibility of understanding paintings as multi-layer objects that you can play with, and you can really get to understand their complexities through this methodology.
Because I was exactly wondering if it will be an exhibition or not. Maybe, well, you proved that doing exhibitions with the replicas, sharing with the public this really specific way of seeing a painting is possible in Bologna, of course, but also the Rubens exhibition you were explaining to us. And how is the feedback from the public? Because I think there is part of the public that maybe is not really used to seeing things like this.
Well, so for example, in this experiment that we were trying to do in Bologna about showing paintings in white without the color, the response is very, very positive, because some people have said that after looking at something like that, then they go back to let's say a normal exhibition, and they are not looking at paintings the same way. They are trying to look for reflections. They are trying to maybe look for these imperfections on the texture in order to appreciate this layer of the character of the originals. There is also another interesting issue, which is the combination of facsimiles or replicas, if you want, with originals in the same room, in the same space. And this is something that we want really to encourage more and more, because we believe it has a lot of potential to explain narratives that are not possible to explain if you only depend on bringing together original works of art. For example, in last year, in 2020, when there was the anniversary of the death of Raphael, there were many exhibitions about Raphael. One of the most important was the one in Scuderia del Quirinale in Rome. They were bringing the best masterpieces from different museums showing original works by Raphael. We had the opportunity of bringing a replica of one of the Raphael cartoons. This is one of the 7 huge cartoons that are in the Victoria and Albert Museum in London. So we were showing this replica together with the other original works. If the museum wanted to have this object as an original, it would have been impossible, because it's one of the objects that are probably never going to be traveling because of security, because of conservation reasons. So having the possibility of looking at a facsimile surrounded by the originals, it was increasing the experience completely. And this is clear for objects that cannot travel, but also if you want to present maybe objects with a different digitally restored version. If you want to show, for example, an object, but in a way that, for example, it's with the colors that could have had in the past, or if you want to try different hypotheses of restoration, this is many times, this is only possible when you are playing with the replicas and when you are playing with facsimiles. So we really think that the positive responses that we are getting more and more with these combinations of replicas and originals, it will only be growing in the near future.
Thank you. Let's see if on YouTube, not yet, questions on YouTube. I had another curiosity. You were showing us the SETI scanner used to record a manuscript in the Biblioteca Nacional de Madrid, and I was thinking, what about books? I know that you said that in this course and you're more into paintings, but if you have to think about recording books in their 3D shape, in their materiality, would it be Lucida part of the recording system?
Yes, absolutely. We have a series of projects about recording books. Most of them are focused on recording the color. Actually, with the Cini Foundation, we have been doing a lot of projects related to recording miniature books, manuscripts, illuminated manuscripts, focused on the color. But then also, as you could see in that example, it is very interesting to be able to capture the relief of pages of books with a scanner like the Lucida. And not only with that, there will be other systems that could give us even higher resolution that I will be discussing in the next days. And with those systems, and with the Lucida to a point, it is possible to see not only the shape of the page. As you can imagine, pages of all books are not flat. They have their own distortions. They have aged in different ways. But also, sometimes parts of texts have lost the ink. They have lost the color. So only the incisions can be captured. Only the traces that have been left, which are actually low reliefs, it can be captured with a high resolution 3D scanning system. So this is one very interesting field of application of 3D scanning technology. What happens when you are trying to read texts that have lost their ink, they have lost their pigment, whatever medium, whatever technique it is, but still it is possible to see some of the footprint, some of the marks that are present in the relief of the page. Very interesting projects are happening also with the Bodleian Library in Oxford. I think Adam Lowe mentioned some of these initiatives in his talk a few days before, and I will be also discussing these applications, because it's not only about making replicas. It's not just about the possibility of making reproductions. The research and the analysis capacities of these technologies is very very much is a growing field of expertise, and we want to be ahead of that, certainly.
Thank you. Also, in December, we plan to have a lecture by a professor, and his field is specifically, he's Italian, and he will focus on the three-dimensionality of a book, and so from different point of view. So
exactly,
it will be interesting to have to.
I will look forward to see that. So at the end, the Lucida scanner, just to give you a general overview, it's something that is very specific for a certain type of objects, which are paintings in gallery spaces. So it would be possible to try to achieve higher resolution. It would be possible to try to make them more accurate, but you would be doing that sacrifice with putting into sacrifice other advantages of the system. Certain 3D scanners are perfect for a laboratory environment, for a very specific context in which you are analyzing small objects in ultra high resolution. But then if you want to bring these systems out to the real world, to a museum gallery, to an Egyptian tomb, then it is impossible to actually complete the job. They work very well in a specific demo, in a very specific section of material, but when you want to apply that to a full collection of paintings, it's not the same. So we wanted to create something that literally it could be used in a systematic way in museums, the same way as they are applying infrared photography, X-ray technology, etc. But there's always a compromise. There's always a balance that you need to find between achieving the best possible resolution and making also a system that it's really useful in all types of context.
Yes, it's necessary. I invite people who are listening to feel free to make their questions in Italian or in English, typing or asking to speak. And because I have another curiosity, but and we wait for the next questions in the meantime. And about what you just said. Well, how to put it? I was curious about the method, like the workflow during a recording of a piece. I think it differs pretty much depending on where you are, if you are in Egypt or if you are in Victoria and Albert, but maybe there is some pattern.
So yeah, it depends a lot of what you are trying to achieve. Normally we are trying to, this is in general for all the Factum projects, we try to adapt to the specific necessities of the project. So we don't have standard procedures, but we need to adapt to whatever is necessary at every moment. The importance of a scanner like this one is the actual scanning head and the software. So that's the core of what we have developed. And then that thing can be adapted to different structural configurations. So we can work in a small room just for recording a manuscript so that the scanning head is mounted on a small frame on top of a table, let's say in a desktop configuration. On the other hand, we also have the necessity of recording, let's say, one of the big cartoons by Raphael, which are about, I don't know, 35 square meters, only one piece. So then it's about finding ways of sorting out logistical issues to put that scanning head on very high positions, making sure it's stable and coherent all the way through the work, so that we can keep the same resolution, we can keep the same level of quality, no matter how big is the object that we are recording. There are other objects that require, for example, to mount the scanning head into a horizontal frame. So when we are recording tapestries, which is a project, for example, that we are going to be doing in Mantua, for instance, it's about recording tapestries in 3 dimensions. It is possible that the actual objects had to be laying down on the floor horizontally, so that then the scanner will need to be adapted to that. So it's one of the advantages of having developed something that is not a commercial system. So we didn't make this as a package that you can sell. It's something that is adaptable and flexible. And the important thing at the end is the shape of the line of laser on top of the surface, and the way with 2 cameras we are recording that line. The rest is something that can be adapted and can be evolved with time. What is essential for us is the way that we are being able to capture this laser line on top of the surface. That's the essence of what we are trying to do.
And I think, thank you. I think tomorrow we'll deepen also into this course, since tomorrow will be more practical.
Absolutely. I will try to explain every detail of how it works, so that people could get an idea of what's the challenges and what is the difficulties and the possibilities involved in this type of systems, this type of equipment.
Yeah, so anyway, also speaking on how being adaptable and having a non-commercial tool is useful and important, it's inspiring. Of course, since we are Factum and Fondazione Giorgio Cini are partners in and going on with the project ARCHiVe, we share this view of adaptability and in-house building what is necessary for the collections, the archives you have or you have to register.
Absolutely. I mean, at the end, we are foundation. So our primary goal is to promote the conservation of our cultural heritage and the promotion of the importance of these objects for us as a civilization. So we are not so much focused on the profit. These type of projects are really never about commercial scope. It's more about how can we really preserve these objects for the next generation. So since we started working in 2001, recording a small section of an Egyptian tomb, to the work we are doing together with you and with EPFL, it's about how can we promote as much as possible, how can we extend these technologies into becoming part of the everyday practice for preserving culture. And this is a very particular approach, because we are always trying to differentiate cultural objective from other ways of understanding works of art, maybe more related to tourism, to leisure, to this type of activities that in a way are simplifying what means a work of art. We are, on the contrary, trying to unfold all the complexity of works of art, and looking at the skin from a 3D point of view is one way of doing that. It's a way of really making visible the complexity of things and the importance that they can have in our culture.
We have, I think, the last questions, because it's almost time to stop. Then maybe it will be anyway deepened tomorrow, but it's about what about curved surfaces? Because yeah, what about curved surfaces?
What about them? What about curved surfaces? It's a great question, because it's something that really is the limit of our system. So the Lucida scanner is something that has been developed for a maximum of 2.5 centimeters of depth of field. So everything happening in a maximum depth of 2.5 centimeters can be captured by the scanner in one single scan. Then it is possible to maybe combine more than one scan if we have the necessity of recording areas that are more deep than that. If we are talking about a curved surface, that is really like a section of a sculpture, we would normally combine the Lucida scanner with other methods of recording, which are, for example, photogrammetry, which is the technique of capturing 3D shape through taking multiple photographs. Or we would be using, for instance, other types of triangulation scanners, like white light scanners that are more specific for sculptures or for 3D volume objects. So each system has its limitations. And in the case of the one that I've been talking about today, it's clearly focused on what we consider not 3 dimensions, but 2.5 dimensions, which is in halfway in between being completely flat and between being a 3-dimensional object.
Almost flat, but not yet flat. Yeah. And I think, so this is plus with the Rubens, bozzetto.
So the
has been flattened before.
So the Rubens is something we recorded before it was restored. So when we recorded it, it was flat.
Okay.
And because it was flat, because it was forced to be flat. So that was causing the cracks, that was causing the problems to the painting. We recorded just before they started repairing it, and part of the restoration involved bringing back its natural curvature to the panel.
Yes, we saw the images, impressive.
And that is actually, yeah, that's what they were doing. And that is what was more convenient for the preservation of the paint layer, to allow the panel to acquire a natural shape. Because what has been happening the last centuries, let's say, is that many panel paintings have been forced to be flat for different aesthetic ideas, for different conservation criteria that we nowadays don't, let's say, we don't approve. And we are more and more tolerant to looking at panel paintings with a natural and very strong curvature, because it is believed that this way it is better preserved, the layer of the paint.
Okay, I don't see any more questions, but yeah, I think that tomorrow we will continue. And thank you very much. It has been extremely interesting. And see you tomorrow.
Thank you for inviting me, and thank you everyone for attending and for your questions. I will see you all tomorrow. Thank you very much.
Bye-bye.